Hello, everyone. My name is Steven, and I work at Oracle, and I'm going to be talking a little bit about compact Debuginfo formats and how I think that they can help us rethink some of our tooling, Linux tools that we use, that we're writing, things like that. So I work, again, at Oracle, and the reason that that's important, I work on the sustaining engineering team. And if you're familiar with sustaining engineering and in enterprise software companies, that essentially means that I fix bugs in old released products. Whereas a lot of people here are probably working on the latest, greatest upstream kernel, adding new features, things like that. I am spending more time on fixing bugs in a production kernel that a customer is using, which has its own set of challenges. In particular, I think a lot of customers don't really like Debuginfo. It has the word debug in it, and it's a little scary. So I'd like to talk a little bit about that and how that informs my strategy with debugging and also just the broader set of Linux tools we have. OK, cool. It's that button. And so my thesis for this talk is essentially, if we change a little bit about how we think about Debuginfo, then we might find that we can add new, interesting capabilities to tools that we're already using, or build new, interesting tools. So to start, before I do that, I want to kind of give an overview of what Debuginfo looks like in a couple different examples. Please bear with me. This might be really obvious for some of you. It might be just a good foundation for everyone, though. So imagine you've got your Hello World program, right? And if you're like me and you started learning C, you wrote a lot of bugs, and so you needed to immediately learn a debugger in order to start working and to figure those out. So imagine you compiled that program and then promptly stripped the program, removed all the useful information out of it, and you run it with GDB. Then you try to set a breakpoint, and I guess I can highlight, yeah, breakpoint right there. But yeah, GDB can't find the breakpoint or it can't find main because there's no ELF symbol table anymore. And so when you run, it doesn't do anything. It can't stop the program at main, and it just finishes. Rather disappointing, but that's pretty obvious because you stripped all the useful information out of the program, so that's kind of on you. The next option is, say you didn't use strip, you actually left it as it was, then you can do some debugging. You load GDB and you set the breakpoint, and it does find main. But then if you try to step through it, let me highlight here, using the next command, GDB doesn't know what line number is the next instruction. So normally it would set a breakpoint on the the address of the next line of code, but it can't do that here. So it just continues running until it finds a line that it knows about. And in this case, I happen to have glibc debuginfo installed, so it stopped there. But more accurately, it would probably just exit out. And again, you wouldn't really get much debugging features. So then obviously the thing that everyone would say from the start is use -G when compiling, and you'll get your DWARF Debuginfo added to your executable, and then you get the full fat GDB debugging experience. Compared to the previous slide, there's a lot of interesting things here. First of all, when you set the breakpoint, you get a file name and a line number pointed out to you, whereas previously there was just an address. And when you actually hit the breakpoint, you get that file name and line number again, but you also get arguments and their names and their values. And as you step through the program, you get the line numbers, the file name, and you get a printout of the source code. And some things that aren't necessarily demonstrated here, but GDB will also be able to interpret more complex types, structs, unions, all those things. So again, I don't think that this is too new to anybody, but it's a good foundation. And it kind of illustrates what I think is the classical approach to Debuginfo, which is that you get nothing until you use -G, and then you get everything. you get a really great debugging experience with DWARF Debuginfo, but distributions are going to compile that, and then they're either, if you're Arch Linux, they're going to throw it away. They don't do that anymore. They save some of their Debuginfo. That's great. But otherwise, it depends on the distribution. Most of them are just going to put them into separate Debuginfo packages, and the reason being that DWARF is really big. And so that means that runtime binaries they'll have some information, rather minimal, kind of like the second example I showed. And if you encounter a crash, then the typical maybe more legacy or simplified approach is that you're going to need to have your customer, your user, install a Debuginfo package, and then they can run debugging commands, or they can generate a report, or they could send you their entire core dump if they'd like, something like that. This is admittedly a simplified approach. There are other examples of some improvements. I think Debuginfo-D is great, and there's a lot of different crash reporting options out there that I would encourage people to explore. But at least in my experience, what I find a lot of the time is that if you encounter an issue with a customer, you're going to need to get them to install Debuginfo. And like I said, I find a lot of customers, at least in the enterprise world, are really allergic to Debuginfo. Sorry. And I don't think that I have a gripe. That is the classical approach that I think we're all familiar with, and I have a gripe with it. I think that Debuginfo is a kind of a bad word for two reasons. One is that it's misleading. It has the word debug in it, which I know I've been harping on. Customers don't like it. But I think that also it's a little bit misleading that you could use this information for a lot of different cases that aren't just debugging classically like GDB, stepping through a program, things like that. You could use it, you might want to unwind your own stack as an application. You might need to learn something interesting about types at runtime. I'll talk a little bit more about that. The other thing that's not great about the word Debuginfo is that it's not specific. So in that example I was showing, GDB was doing a lot of different things. It was looking up, it could understand types. It was getting a relationship between variable names and their types. It was finding variables by address or by name. It could do source mapping. It was doing a variety of things with stacks. It could even have shown you macro definitions with the right setup. So there's a lot of specific functionalities, and just using one word to say that is a little bit difficult. It's the best we have, and I'm not actually here to propose another word. So I think what it boils down to is that when we say Debuginfo, we usually just mean DWARF information. So to expand a little bit on things that you might be able to do if you have Debuginfo that are not debugging, if you think about a high-level language like Java or Python, you can do reflection and runtime code introspection. And Python would be a hilarious example of just how much you can do that. You can look at the dictionary of global variables or local variables. You can enumerate everything that's in a class, or you can unwind your code. You can actually inspect the bytecode of the code that you're running, which is a little extreme, but good for you. So they don't say that they're using Debuginfo. I mean, in Python, it's not using Debuginfo. This is just evidence of the fact that it's a dynamic, interpreted language, and so all of this stuff has to be available in order for the runtime to actually execute code. But C doesn't really have as many of those features for reflection or runtime introspection, right? There are a couple interesting examples. There's, like glibc has the backtrace function, and I'm not actually sure if that's a standard or not, but it's a really interesting function that will only work in certain cases. I mean, if I ran that stripped binary and tried to do the backtrace function, I'm pretty sure I wouldn't get a backtrace. So there are other interesting things that modern compilers can do, like static assertions at compile time. Yeah, we got a question over there.
FYI, if we do get SFrames in the kernel, glibc will have a way of doing backtraces reliably.
Oh, yeah, I mean,
Just FYI.
SFrame, thank you, Steve. Yeah, that's, SFrame is going to feature highly in this talk, don't worry. Yeah, so compile time assertions are another good example of things that are reasoning about types. For instance, I think in the toolchain track, you would have heard Keys talk about the different ways that you can do annotating arrays with their length in types, things like that. And so that's useful for hardening, but also other features. So the thing is that interesting ability to like assert or reason about types completely disappears after compile time. So you had this great ability to reason about your types, and then you lost it after compile time because there's no C runtime. Cool. Might take a brief. Okay, I am seeing some interesting comments here from Conan. I'm sorry. I'm going to keep going here. So the kernel is especially interesting because because compared to other C applications, there's not actually, normally C applications don't have much of that information available, but the kernel actually already does have stack unwinding metadata, it already has symbol metadata built in, and it already has a type system, BTF, that's usually around. So unlike a normal C application, which might not have all of this ability, this is all sitting right there in the kernel. So let me just briefly talk. I know I mentioned a little bit about the types of data that you might find in Debuginfo. I think type definitions, they can tell you things about the size of an integer or like what members of a structure are present. Then you've got, mapping function names and to their addresses or to their types. Same with variables. There is stack tracing and unwinding, which are slightly different. Stack tracing will give you a list of functions that are currently executing on the stack, whereas unwinding would give you variables, registers, any extra context about the execution of that function that is not simply just what function address is currently executing or about to be returned to. You've got the source code locations, inline functions, and macros. So, and notably, there are, depending on what source of data you're going to use, and I'm going to talk about those more, there might be some limitations. So I'm just highlighting that here, but I'll kind of explain a bit more in a second. So I've talked a lot about DWARF and Debuginfo, but there are other types. So things I consider Debuginfo kind of range from maybe like if you had an alignment chart or something, the lawful good, the normal Debuginfo things, all the way down to maybe weirder things to consider Debuginfo, but that kind of fit the bill. So obviously like DWARF, compact type format, which CTF, BPF type format, BTF, are purpose-built. They contain data about the types and other things. SFrame, again, a purpose-built format that actually has stack tracing data. ORC, similar but specific to the x86-64 kernel. And then ELF symbol tables also, I think, qualifies Debuginfo. But more specifically, there's some other unusual ones like Kallsyms. I think that you might think of that as a Debuginfo format. Plenty of tools will use it. A kind of interesting Fedoraism that I love is GNU debug data, which they essentially find symbols that are useful to have but not at runtime, and they filter them out of the binary and then put them into a separate ELF file that they then compress using LZMA and then put that compressed object into an ELF section of the original runtime binary. It's a little convoluted, but it works, and GDB supports it, drgn supports it, a few other different systems support it. So I think that's a really interesting option format out there. And then now into the more odd things to consider Debuginfo. I think LBR, last branch record, is Debuginfo, but it's a hardware feature that lets you see the most recent function executions or branch instructions, perf can use it when you're doing perf recordings, and so it's an interesting way to get stacks if your hardware is capable of it. But yeah, and then frame pointers. I think maybe that's not unusual to consider Debuginfo, but it's not in the classical sense of a format or something like that. So I kind of thought it would be cool to put all this into one table to illustrate what each of these things do. And the obvious thing that stands out is if you can use DWARF, probably use it, right? Like it does all of these things very nicely. So, but another interesting thing to look at is that if you want, you can kind of pick and choose a few of these other things on the right and piece together something that might be useful for you. I think that's a really interesting takeaway. Now, I've marked, and especially if you are in an environment where DWARF isn't an option, like if you have customers who really don't like that, then that's an interesting thing that you should take advantage of, is to use some combination of these other formats. So I did note a few of these things with kind of a warning sign, and I'll kind of just illustrate them. So the DWARF macro definitions, they only come about if you add some extra debugging flags. You're not going to get them by default. The BTF currently only contains information types and addresses for per CPU variables. So it doesn't include all global variables, and it does include functions. So all functions, all per CPU variables, not the remaining variables. I'm not entirely certain why. I know there is a reason why. I'm actually working on trying to make that change. And then these two LBR and frame pointers, I just put little remarks on them because frame pointers you can't really use to unwind in all cases, especially asynchronous stack unwinding. The idea is that, you know, if you have a frame pointer you're setting up, then in the code that you're setting up the frame pointer, if you get interrupted and you're trying to unwind that stack, then you won't be able to unwind it. So that's not really ideal. And then LBR, it's not really ideal because you'll have to have privileged hardware capabilities. So the OS perf can use it, but not in any other situation. And it also has a relatively limited stack depth, I believe. But yeah. So yeah. I think I mentioned these observations already, but yes, if you can combine a few of these non-DWARF options together, you get something really potentially useful. We've been doing this in drgn, which is a debugger that I think I'll talk a little bit about later. And I think also I've already said the kernel is unusual, and having all of these, or several non-DWARF formats available. And then I think another important thing to point out is that a lot of useful non-debugging features don't require everything that DWARF has. So the reason I want to talk about rethinking these formats, or rethinking Debuginfo in general, is just because you need debugging, a couple features of a Debuginfo format doesn't mean you need to have all of DWARF. Maybe you could just pick and choose a few things and put them together. So what I want to go then about is talking about a few case studies historically of how compact formats are useful in different Linux applications and tools, and then kind of talk about potential future ideas. And hopefully other people are already a little interested and might have some thoughts too, because I was thinking kind of how Stephen likes to say this, that the micro conferences are more about brainstorming. Maybe people have some thoughts too. So, but this isn't a microconference. So my first case study I wanted to kind of mention is the PS utility. I remember reading in LWN, when DevKMM got removed, about how very old PS applications, like around Linux 0.98 or something like that, and maybe other applications too, the way they worked was not by reading the proc file system, because that had yet to be invented, or at least implemented in Linux. So they worked by opening DevKMM and reading out the task structs that were on the system, which is honestly Pretty smart, pretty cool. A little bit dangerous. Probably wouldn't be doing that in a modern enterprise system or whatever, but hey, it had a downside, of course, besides needing to be root or set UID, that this needed to be rebuilt on every change to the kernel, or it might need to be rebuilt because someone could add a field or something to any struct. And so without type info, you just had to rebuild the PS application. But now, of course, you can use the proc file system, and that's definitely the better option. But not everything actually needs an API or an ABI, right? Proc file system, great. Glad we have it, but maybe getting debug information out of KVM, maybe getting strange specific information out of subsystems that you as a developer or as a power user want to know about. It shouldn't have an API or an ABI for user space, but maybe with those compact type formats, you can make something kind of like this that works with drgn or something like that. So that's just one area where I think compact type formats could be helpful. Obviously, PS solved this issue with the proc file system, but one place where that very, very similar problem was solved in a totally different way is with BTF and co-re. So BTF programs had the same exact problem, that you would need to ship BTF source code, and you would need to compile it on your target system because the structure offsets might be different on every kernel that you might want to run the script on. And so you needed to have Clang compiler available on your target system and all these things. Nowadays, when you use BTF, you can use co-re. You compile the application once on or the BTF code once where you're writing it or building it, and then you can ship it off to where you want to use it, and you'll actually get relocations where I just chose dparent here as an idea that if that offset ever changed, co-re would be able to update the offset that you read in your BTF program, and your program would automatically adjust. So had there been a BTF co-re in Linux 0.98, maybe we never would have implemented the proc file system. I'm glad we did, though. So yeah, and that obviously eliminates the need for compiling BTF on the target system. So another case study that I think is really interesting in compact type formats being useful is drgn, which I mentioned briefly. It's a programmable debugger. It's a Python-based debugger that it normally uses DWARF for Debuginfo. But if you want, then we've been working on features to enable debugging without DWARF. So we, in a few releases back, added the ability to load Kallsyms and use it as a symbol table like it had been in the ELF, as if it had been an ELF symbol table. We added the ability to read the ORC info out of a x86 VM core and start using that to unwind stacks, or do stack traces, I guess, without needing to find that data out of an ELF Debuginfo file again. And then for looking up types and variables, we've got a pull request out for using CTF, which you can find in Oracle's UEK kernels, but BTF and CTF are actually very similar, and we're actually hoping to converge those formats together so that we won't have these two separate bullet points. Ideally, it would just be, you can use BTF to look up type and variable of different things. But like I mentioned, global variables aren't available yet in all BTF. So. Yeah, that is drgn and dwarfless debugging. And then this is something I mentioned kind of when I was explaining what GNU debug data is, but Fedora has this GNU debug data feature, and their problem, of course, was that they wanted a similar thing that I was saying with drgn, that it would be really nice if you could get a stack trace or out of a core dump or a user's application that crashed. And their issue was that while they actually have EHFrame, dwarf CFI, unwind information available on all runtime applications, I believe it's necessary for C++ exception handling. So everybody just has dwarf unwind info in all of their runtime binaries right now. But they had the ability to unwind all of their stacks, but the issue was that they didn't have symbols for everything, and so when you get a stack trace, half of it would be, hexadecimal addresses, not very useful. And so GNU debug data was the solution for that, where now you can get a stack trace that has useful information that you can send off to developers without needing to send a core dump. So that's a pretty useful idea. I'm going to stop to see what Neil said. Yes, I just figure Neil knows more about this given his situation. So yeah, all right, that is Fedora. I have one other past idea about compact formats. I didn't really include it in my table, but I think VM core info is a really useful way to think about a compact Debuginfo format. Make-dump-file, as I think many people are familiar with, is a tool to make a compact core dump out of the proc VM core when a crash happens in the kernel. And in order to do that, it needs to know things about like the offsets of fields in struct page. It needs to know about certain symbol locations so that it can find the root page tables. It needs to know, at the end of the day, it just needs to be able to make a determination for every page. Is this useful to include in a core dump? And you can use DWARF Debuginfo to do that. Don't get me wrong, it has the ability to do that, but that's a bit of a pain to use. And especially in the kdump environment where there's limited memory, limited everything, honestly. So they instead took those hundreds of megabytes of DWARF data and shrank it down to a 4 kilobyte piece of text that they read out of the VM core, and it has all the information they need. A few symbols, a few structure offsets, some other information there. And I think this is a really kind of fun example of how compact formats can be useful, but I think it also kind of begs the question, like, what could make-dump-file do with even more compact Debuginfo available? So I started working on an implementation of BTF and Kallsyms, and then Tao Liu noticed that I was doing that and said, hey, didn't you see my patches on the mailing list? And so we'll try to work together on this rather than having separate implementations. But the idea is that, hey, VM core info is great for the basic idea. I just want to filter out certain pages based on very coarse classifications. Is it a user page, a page cache page, or is it a kernel page? Or a 0 page, or whatever else. But if you want more features, like maybe you want to exclude GPU buffers because there's a lot of them on your LLM training machine or whatever, then that might be a good idea to exclude. Or maybe you want to be able to do stack traces of the user space applications just before a panic happened. I know the situation with a lot of my customers is that we have a system that will crash the kernel in case of a very bad user space situation, and that way you quickly get back up and get into a known good state. But then the problem with that is, like, why did we panic now? All I can see is that there was a write to the proc file to crash the kernel. So this might get you the ability to look at a stack trace for what was actually going on for the application that triggered this core dump, or the panic. So I think this is, no promises. I think this would be a really interesting way to expand make-dump-file in the future. And now we've gotten to basically my last spitballing page, and I don't necessarily want to say that any of these are great ideas. They're just things that I was spitballing when I came up with these slides. One thought is that GDB and drgn do a great job of printing out structures that are formatted, printing out memory that's formatted in a way that's useful to a developer rather than as a hexadecimal dump or something. So it might be interesting to see about a way that printk could just obviously not in production, but if you're a developer and you're looking to just get a quick printf debugging feature, maybe you could get something a little bit more user-friendly by using the CTF or the BTF and actually interpreting the type of that argument that you gave. You could maybe see something like that, being part of glibc even as a very silly concept. Enum values converted to strings. Obviously, this is something that you could do with some sort of static feature from the compiler side as well. I kind of wonder why that's not a thing yet, but probably because it's open source and I haven't submitted a pull request. Maybe with perf, there's the idea of using perfmem or perfc2c to look at memory accesses and see which accesses are triggering certain cache line sharing, false sharing issues, or other memory-related issues. And it would be interesting if you could do that rather than looking at memory addresses. If you could say, well, this is a slab address, and it has this type object, and I can tell you that that's the offset of this field in the kernel. So we have false sharing on this structure in this field, or this symbol, or something like that. I think that would be an interesting way to wire up some of these compact formats. ABI checking is an area where CTF and BTF are already getting used in libabigail, I believe. And I think there are probably other options that I'd love to open the floor out in discussion or questions. The only other thing that I had here was the idea that BTF and Kallsyms are actually sharing a lot of the same data. So in terms of string tables, we could probably do something, given that these are sharing a lot of the same information, we could probably combine them in some interesting ways too, so to further compact the formats. But let me see, yeah. That brings me to the conclusion here, which is basically DWARF, really excellent if you have it. If you can use it, definitely use it for debugging. If you can't use it, there are a lot of options out there that can form a minimal alternative to DWARF. And finally, things like these compact formats don't necessarily need to just be used for debugging. You can pick and choose a few things together and use them for some interesting introspection, kind of like you would see in a higher level language like Python. Turn C into Python, I don't know. And yeah, I think there's a lot of room to rethink different tools and applications that we're already using to make them more user-friendly based on this sort of approach. So that's everything I've got, and I think I'm a little bit short, or not short on time, I'm a little, yeah, we've got 10, 15 minutes for questions, or we can have an early break. So thank you.
Yeah, thanks for your talk, and thanks for mentioning the data type profiling in perf to match the PMU sample memory access information to data types. So we have it right now, but what's missing, not missing, but the needed information is to match the data address and actually the source code address to match the data type it accesses. That requires the source location information, which is provided only in DWARF. Yes.
So it's the source. So you're trying to find. It's not the offset in the structure. You're actually looking for code addresses.
Yes, because not just offset in the field data type, it needs to find which data type it accesses.
Yeah, so that was why I was potentially suggesting, as a different approach, you could look at the type of the page and see whether it's a slab page or something like that. And if it's a slab page, you can figure out which slab, and you can get a good guess at which type it is as an alternative.
Yeah, we do have that, but even in slab, doesn't have type information.
If the slabs are merged, then yeah, there's, and the slab doesn't have type, annotated with it, you're right. I do think it would be really cool to have an annotation. And as the kernel hardening approaches are trying to make every slab page have it, or slab cache be specific to a kind of type, that might even get easier in the future.
Right. Okay, thanks.
Yeah, thank you.
Other questions? looks like there are a lot of
Yeah, a lot
discussion,
of discussion going on.
Yeah, generated quite a bit of discussion.
Okay,
Great.
that's great. Yeah, I'll read through it once I get off the podium. All right. Well, thank you, everyone. Appreciate it.